Good morning, afternoon, or evening, depending on where you are in the world. My name is Lydia O'Meara, and I am a nutritionist and a second-year PhD student with the Natural Resources Institute, University of Greenwich. Today, I will be presenting preliminary findings on the nutrient adequacy of women's diets in rural Eastern Uganda. I would like to first acknowledge my co-authors, and also the research partners and donors of this project. By way of background, we know that eating a diverse, high-quality diet is important for nutrition and health. However, micronutrient deficiencies in women of reproductive age, that is those that are aged between 15 and 49 years old, are a persistent public health concern in sub-Saharan Africa, including Uganda. For example, 1 in 3 Ugandan women are affected by anemia, similar to the global average, and twice the prevalence compared with Ugandan men. Globally, micronutrients with the lowest levels of estimated adequate intake are calcium, iron, vitamin A, and zinc. This is concerning because micronutrient deficiencies are important for normal bodily growth and function. And if someone has a micronutrient deficiency, it can lead to a range of related diseases and health conditions. For example, in the case of low iron intake, it can lead to iron deficient anemia, reduced immune function, and other things like impaired growth, and even in some cases, mortality. However, little is known about the nutrient adequacy of women's diets in Uganda. Therefore, the objective of this study was to 1, identify problem nutrients for women of reproductive age in Kamuli and Bugiri districts of Eastern Uganda, to identify potential locally available and acceptable foods to help meet nutrient gaps. And 3, to explore food sources of nutrient-rich foods in the local food environment. So for this study, quantitative weighed dietary data was collected for rural women aged 18 to 49 years in 2 districts of Eastern Uganda for a total sample of 202 women. And these were based on 15-hour observations and recall of any food that was not absorbed or that was eaten outside of the 15-hour time window. This was conducted in January 2018. Data was analysed using linear programming analysis with the World Health Organization OptiFood software to determine the probability of current dietary patterns achieving recommended nutrient intakes. For the sake of these preliminary findings, the problem nutrients were defined as consumption of less than 75% of the World Health Organization recommended nutrient intakes for pregnant women, lactating women, and non-pregnant or non-lactating women, or in other words, the general cohort of women of reproductive age. This bar graph shows the mean nutrient intake of women's diets relative to the World Health Organization recommended nutrient intakes. Along the top here, you can see the bars that demonstrate the groups of women that are most likely to reach 100% of their RNI. And along the bottom, you can see the 13 nutrients that were analyzed. This included the macronutrients protein and fat, vitamins A and C, the family of B vitamins, including folate, and the minerals calcium, iron, and zinc. The red lines in the middle indicate the mean nutrient intake of each group of women relative to the 75 and 50% thresholds. We will explore this in a little bit more detail in the next slide, but I would like to quickly draw your attention to the nutrient gap here on the right that is showing up for calcium, fat, and iron. As we saw in the last graph, fat, calcium, and iron were the nutrients of concern for all of the groups of women. However, if we break the analysis down for each of the physiological states, we can see that there are other nutrients of concern. For example, for pregnant and lactating women, folate, vitamin A, and zinc are also important. We then looked at what local foods are available that are high in these nutrients that could potentially be promoted to enhance these nutrient intakes. As you can see from this quick list here, green leafy vegetables and small dried fish, especially those that are eaten whole, including the bones that are high in calcium, punch above their weight when it comes to delivering multiple micronutrients. But where can women source these foods in their local food environments? Upon further analysis, we found that the majority of ingredients that women ate were sourced from formal shops, home production, and informal markets. Notably, when we dig deeper into the data, we found that nutrient-rich animal-sourced foods were more likely to be sourced from informal markets, while the staple foods like maize and potatoes, vegetables, legumes, and nuts were more likely to be sourced from home production. By comparison, more nutrient-poor foods like sugar, salt, oil, tea, and highly refined wheat or rice products were more likely to be sourced from formal shops. In conclusion, the findings of this study indicate that fat, calcium, and had the highest nutrient gaps for all women, regardless of physiological status. However, analysis conducted for the whole sample masked disparities in the adequacy of nutrient intake for pregnant and lactating women. And this highlights the importance of disaggregating dietary data by physiological status. Of the 7 local foods that have the potential to enhance nutrient adequacy, small fish and dark green leafy vegetables address 4 to 5 of 6 problem nutrients. And steps moving forward, future research will evaluate the feasibility of food-based recommendations to help close as many of the nutrient gaps as possible, and also assess the relative importance of different food sources within local food environments to diet quality. Thank you for listening, and happy to take any questions. List of references are here. Thank you.